This is a fake candle, and it's different from most other fake candles in that it actually has a plastic flame that wavers about in front of an LED. Now, the moving flame type candles aren't radically new. This one, however, is one of a current batch that seem to be coming out from different suppliers. One of the most notable brands, and quite an expensive one, is Luminara. However, this one's not Luminara. This is a typical Chinese Christmassy brand called Premier, and this particular candle is called the Premier Dancing Flame Candle. And they all seem to work on the same principle. They have a plastic flame lit by an LED, and there's a magnet on the bottom of the flame that makes it waver about. Now, this one looks pretty convincing, I have to say, but it does have a slight design weakness. If I change the batteries across to, I've got fresh batteries in it. I noticed they were selling these on Amazon, and I got this one off eBay. But one of the most common complaints was that the batteries didn't last very long, and then it would start flashing. And they're absolutely right, it does. If I put those alkaline batteries in that are pretty flat, after a while, the thing starts flashing and pulsating really annoyingly. And the reason for this is very simple. The circuitry uses a step-up converter to raise the voltage from the batteries to light the LED, and because it's only two AA batteries. And the coil that flicks the flame about is actually really low resistance. It's a 22 ohm impedance coil, and as such it draws quite a bit of current. So whenever that light dips out, that's the voltage being pulled down below the point at which the converter can put out high enough voltage, and that shows when the coil's actually being energized, which is quite a lot of the time actually. It really does energize that coil a lot. But anyway, enough of this, let's open it up, shall we? The answer to that problem, by the way, is just to use good quality nickel metal hydride rechargeable batteries, because they hold their voltage right up to the very end, and that should hopefully solve that problem, I should think, of the flashing. That's quite annoying now, so I'll turn it off. The unit, oh, look at the big hole in this, I broke it while I was opening it. It's made of wax, by the way. There, that happens. There's a switch in the bottom that switches between off, on and timer. So I'm just going to pop this out. The whole module slides out, splitting the wax in the process. It used a really gooey glue. I'm not sure what it was. Anything that sticks to wax must be super gooey. So there's the little plastic flame that flaps about. And to give you an idea how that works, it's got a little plastic scoop, that's this bit here, a wire to align it. Now the wire has a little dip towards the back, and that keeps the flame aligned centrally, and also it makes it always inclined to the back so that it can be lit from the front of the LED. There's a little plastic counterweight with a tiny magnet, and then there's the coil. And an LED, of course, lights it from the front. Now, I was kind of almost expecting this to be really simple inside. I know it's got one of these timers that turns it on for about 6 hours a day and then off for about 18 hours. So you know it comes on in the evening and turns itself off, and then every day it just repeats the same cycle. It's a very simple way of basically having a automated time system rather than use a light sensor and trying to, or remembering to turn it off at night time. It will just automatically turn itself off after a 6 hour session each day. So anyway, inside is this little circuit board, and for the timing it uses a crystal. The reason for that is that there's an 8-pin chip controlling this, and I'm guessing that's a PIC 12 microcontroller. It's not actually marked, but all the pinouts are the same. It's a really common chip in things like this. And it just so happens that its power pins are the same as a PIC 12. The pins the crystal are connected to are the same as a PIC 12. And it's almost certainly a PIC 12 or a clone. Now, for switching of the Well, let's start with the power going in first of all. The power comes in, then there's a small choke, and then there's this little switching chip that is obviously boosting the voltage up. Now, I could not find this on the internet. I mean, 2188A, I'm thinking that's the date code. I'm not 100% sure. But I thought this would be the main code. I couldn't find a reference to this chip on the internet. It seems to just be a voltage booster. I'm not 100%. I mean, it certainly is a voltage booster using that choke, but I don't know. Maybe someone else knows. So the voltage is boosted up. It drives the LED almost directly via the chip. The chip, one of the output pins of the chip, switches the LED on, and another output pin from the chip is used to pulse this transistor on and off, which then pulses the coil on and off to flick the flame about. There's also the facility for an infrared remote control, which is just the plus minus and then data out to the chip, but it's not used in this particular application. So inside, well, let's open it then, shall we? First of all, it's very modular. This comes off here like this. Let's take the screws out. This is where it gets a wee bit footery. One screw, two screws, there's just two. Although there's positions for 4 screws, they're not used at the bottom because it is kind of clamped into the base. So if I gently lift this off, not an awful lot in it, the LED is just placed into the frame. The flame is on that little bit of wire, which also just lifts out of 2 holes. It's just a very simple formed bit of what I guess to be spring steel wire. And then there's a circuit board with the coil on it. And that coil, I measured the resistance of it and it came out at 20 ohms. I thought it was going to be a lot higher than that, and I think that's probably why it has that problem with the flashing, because that is quite a low resistance, and at the sort of voltage it's operating at, oh, let's get the calculator. At the voltage it's operating at, say about 3.3 I measured, divided by 20 ohms, it comes to about 165 milliamps. I don't think it is that high, but certainly it's pulsing on and off, and I measured it at being over 50 milliamps average current draw, so it probably is in the 100 milliamp region, and that's probably why it has that effect of dragging down the little voltage step-up chip and making it LED flashing that way. But you know, other than that, when it's running, it's actually a fairly convincing light. It projects a strange pattern behind it onto the wall because it's basically the dot projected by the LED plus the flame wavering in front of it. But other than that, from a distance, particularly if you had a group of them together, as is always the case with the electronic candles, it would be quite passable. It's actually okay. It does the job. Maybe a wee bit over sophisticated in my opinion, but I might have perhaps chosen to use 3 AA's and not even bother with the timer facility, and maybe a higher impedance coil. Not 100% sure. Maybe they really need to kick it hard to get that effect, but it is very good. Oh, and another thing, when the flame's wavering about, it does tend to clatter off the side of the little port it sticks through, which makes a sort of continuous rattling noise, which is a wee bit annoying, but you know, I suppose it's an early design in this era of electronic candles, so it's not that bad actually.